All right, so welcome back. We're going to continue from the lesson I did in the last video where I introduced to you some things called exact values of trigonometric functions. And now we're going to learn how to use them in applications and in trigonometric problems that you might have seen last year. The only difference is now that we are able to derive the exact values of those trig functions of some standard angles, now we can start calculating without even using a calculator and determining the exact value of answers.
As long as the angles we're dealing with are standard angles that we've dealt with. So some of the angles we've dealt with so far are 0 degrees, 45 degrees, 30, 60, and 90 degrees. That's what we've got so far. In future days, we will be expanding the repertoire of angles that we can deal with. But in the meantime, I've donned my magic glove. My magic glove allows me to write on my tablet without interacting with it with my hand. So I've got the tablet set up, and so I put the glove on so that I can go hands on my tablet and use my my little stylus without providing too much irritation and problems for me. We're on page 229. 229, where it talks about special triangles. And what I want to do very quickly is draw the two special triangles so that we can derive the information we need for sine, cosine, and tangent of 30 degrees, 60 degrees, and 45 degrees. So let's do that right now. That looks good enough. So the key thing to remember here is when you're drawing these standard triangles, and I urge you to draw these often. Whenever you sit down to work through trigonometry in this class for this course, learn how to draw these triangles very quickly and very effectively. It saves you having to memorize 9 different values for the 9 different trig functions and the variation that you have for them. All right. So once you draw these triangles, well, what do we have? Well, we have right angles there and there. In the first triangle, we have 45 degrees in both apex. That's a 45, 45, 90 degree. And in the second triangle, we've got 60 degrees for the big robust angle down there and 30 degrees for the skinny angle up top. The second thing you got to remember is that the hypotenuses of both of these triangles is going to be assigned a value of 1. And that's really helpful because if you have that standard 1 unit hypotenuse, then you can very easily, using Pythagoras, derive the side of that length there, the length of that side, as being root 2 over 2. And because it's a 45, 45, 90, the sides are equal. So root 2 over 2 and root 2 over 2 are the lengths of those two sides. Similarly, because this triangle here is really a continuation of that, then this side length here will be 1/2. And using Pythagoras again, we can figure out the length of the unknown side, the tall side of the 30, 60, 90 as being root 3 over 2. All right. So there's our two standard triangles and our standard lengths using the 1 unit length of the hypotenuses in both cases. Let's do 45. Reading it right off the graph, you see that sine 45 is simply root 2 over 2 over 1, and that just simplifies to root 2 over 2. So that's all I'm going to write here. And remember that we got root 2 over 2 by rationalizing the denominator. If you use Pythagoras, you actually get 1 over root 2. And because we don't like seeing radicals in the denominator, we rationalize it by multiplying by root 2 over root 2. It's kind of unique in Alberta. When I learned this in Ontario, they did not make us rationalize the value for the sides of 45, 45, 90. To this day, I still remember 1 over root 2, 1 over root 2. It's stuck. So because this is a 45, 45, 90 degree triangle, we know that the cosine of 45 degrees is going to be the same, root 2 over 2. And finally, the tangent of 45 degrees is simply going to be root 2 over 2 divided by root 2 over 2, opposite over adjacent, which is equal to a big fat 1. So if we scroll down a little bit to the bottom of this page to the summary table, we can start filling in some values here. Root 2 over 2 is the cosine, or 1 over root 2. You know what? I don't think it matters too much which one we use. Sine 45 is similarly 1 over root 2, or probably more appropriately, root 2 over 2. And finally, the tangent of 45 degrees is simply 1. Cool. All right, so let's now attack the angles 30 degrees and 60 degrees. All right, for 60 degrees, that's that angle down there, sine of 60 is going to be root 3 over 2 divided by 1, or simply root 3 over 2. Cosine of 60 is going to be adjacent over hypotenuse, or 1/2 over 1, or simply 1/2. And finally, tangent of 60 degrees is going to be root 3 over 2 all over 2, which simplifies, well, you can invert and multiply the denominator, and you'll get root 3. And let's plop down now and plop that information into our tables here. All right, sine 60 is root 3 over 2. Cosine 60 is 1/2. And tangent 60 is root 3. Cool. Moving right along. You've got to be able to do this effectively and efficiently. You can either memorize things, which really never works, or learn to derive. Now, honestly, I did not memorize this. I was a good memory kid in school, but there's no need to memorize this. I'd much rather you remember how to derive the values by using these special triangles. And finally, tangent of 30 degrees is going to be, I'm going to do my work down here, 1/2 over root 3 over 2. And when I pop that over there and invert and multiply, I get 2 over root 3, 1 over root 3. So while you have this up, take a moment and take a look at the relationships between the sines and cosines of 60 and 30 degrees. Note that the sine of 60 degrees is exactly the same, has the same value as the cosine of the conjugate of 60, or 30 degrees. And by conjugate, I mean the angle which, when added to the original angle, comes up to 90. So the conjugate of 60 is 30, because 30 plus 60 equals 90. So look at that relationship there. The sine of 60 is the same as cosine of 30. Similarly, cosine of 60 degrees, or 1/2, is going to be the exact same as the sine of 30. All right, so you see how those are related. And finally, the last relationship that would be really cool for you to identify is the tangent functions. Okay, and the tangent functions of 30 and 60 are merely reciprocals of each other. So where tan 60 is root 3, tan of 30, its conjugate, that is the conjugate of 60, is 1 over root 3. It's reciprocal. All right, and that's just a really, really nice set of relationships to notice and to be able to use in your math going forward. So we'll add this into our summary table here. Cosine of 30 is root 3 over 2. Sine of 30 is 1/2. And tangent of 30 is 1 over root 3. And here again, notice that these are reciprocals of each other. Okay? Tangent of 30 and tangent of 60 are simply reciprocals. Notice that sine 30 is the same as cos 60. And note that cos 30 is the same as sine 60. Really important relationship. All right, we have 9 values for 9 trigonometric functions of 3 primary angles, 30, 60, 45. Let's now figure out how we can use this information to A, solve trigonometric questions, without using a calculator, and B, for finding and using exact values for these trigonometric functions, as opposed to finding their approximations by plugging in sine 30 or cosine 60 into your calculator. So down we go to page 330. Here's a prime example that allows us to use some of our newfound knowledge. Solve the following triangle using exact values. You don't need a calculator anymore. Yay! We've graduated into the big time. Well, in the olden days, you would take a look at this and say, well, there's two triangles here, and it looks like I need the information from one of these triangles to be able to solve the other one there, right? And so you might immediately say, well, it would be really nice if I knew what A was. A, the height of the big triangle, the overall triangle. So let's start by solving for A, seeing if we can't figure out A. Well, I know that with regard to the 45-degree angle there, that A over 4 is equal to, what is it? It looks like sine of 45 degrees. But if you take a look at our table of summary up here, you're reminded that we have a value we can use for sine 45. And so we're going to substitute that in, and we'll state it. We're going to say, but sine 45 equals root 2 over 2. And so we can rearrange this formula here. So we can rearrange this formula here and plug in the value we have there and say that A equals 4 times root 2 over 2, just like that. All right? A little bit more simplification, 2 divides into there equally, so A now equals 2 root 2. And because we're dealing with centimeters, we might as well use those. A equals 2 root 2 centimeters. Cool. We've done that. First step. So we know what A is, but we sine of 30 degrees. Okay? And I like that because I know that my A value is 2 root 2. And I also know that sine of 30, just going back up to my table of summary up here, sine of 30 is 1/2. And so if I rearrange this equation here and substitute in those two values there, I would get, let's see, I'm isolating for x. So x is going to be equal to 2 root 2 divided by 1/2. And if I multiply top and bottom by 2 to get rid of the, to clear the denominator there, I'm going to get x equals to 4 root 2. And because we're dealing with centimeters, it's 4 root 2 centimeters. Cool. There's the first thing I really needed to go, and I've got it. I've got my value for x. Let's now figure out the value for y. And to solve for y, there's two things I could possibly do here. I could choose to go y over x, because y over x would be cosine of 30 degrees. And we know what cos of 30 degrees is. Cosine 30 degrees is root 3 over 2 right there. I could also, if I wanted to, and to come up with the exact same answer, go a over y equals tangent of 30 degrees. All right, and once again, I could figure out I know what tangent 30 is. Tangent 30 is, there you go, 1 over root 3. And I'm not going to solve it both ways because I don't want to take up too much time, but I do urge you to give it a try and to confirm to yourself, make sure to yourself that you get the same answer regardless of which method you choose to use. I'm going to use the first formulation that uses cos 30 because I remember that cos 30 equals root 3 over 2. And I know that x just from the question up here, is 4 root 2. All right, so I'm going to substitute, I'm going to rearrange this formula in terms of y. Y is going to be equal to x cos 30, in other words, 4 root 2 times root 3 over 2, like that. And so now we're going to use some of that information we learned in the radicals unit in terms of dealing with multiplying and dividing radical expressions and terms. We're going to do that division there. We're going to get a 2 remaining. And we're going to multiply root 2 by root 3, and we are going to get root 6, right? Because it's the same base power of both of those radicals. It's both square roots, both a root index of 2. And so root 2 times root 3 is simply root 6. And because we're dealing with centimeters, I believe, yes we are, then this is 2 root 6 centimeters. All right. And I believe we've done it. We have come up with 3 side lengths, all in exact values, not approximations. And the only difference between this and the work you did last year in trigonometry is that we now know how to deal with those funky radicals. We know how to derive exact values for each of those trigonometric functions. And so now it's easy to manipulate them without using a calculator, which is the big benefit of learning how to do things this way. All right, so there is a big long question solved with a couple of examples. I'm going to solve one more. I'm going to solve the simple. I'm going to go into question number 1 on page 230. But before I do that, why don't you go take a look at it? That's just right down there. Did I tell you about my funky magic glove? I think I did, right? All right, so pause this video and go attempt question 1 under special triangle practice on page 230 and come back to me when you've done it and let's see if you got it. Okay, boom. Whoa, hey, welcome back. So we're going to go deal with special triangle number 1. State the exact value for the following. State the exact value for the following. We have x on this leg of the triangle. We have a hypotenuse of 4 and an angle of 30 degrees. So our special angle of 30 degrees. So right off the bat, if I want x and I've got 4, then I can make an equation that says x over 4 is equal to sine 30 degrees. You see how I did that? X divided by 4 equals 30 degrees. All right. Now it's asking us for theta as well. We'll do that later. Let's start with it. Do we remember what the sine of 30 degrees was? Sine of 30 degrees using your special 30, 60, 90 triangle is 1/2. And so if you stick with this business, this mathematical business long enough, that's going to just jump into your head as it just did in mine. Sine 30, 1/2. Sine 30, 1/2. All right, cool. So now we can rearrange the formula and isolate for x. X is going to be equal to 4 sine 30, which is to say x equals 4 times 1/2, which is to say x equals 2. As simple as that, an exact value of 2. Now, the difference again between what we're doing here and what we did last year was last year you would plug in 4 times sine 30 in your calculator. Would you believe that if you did that right now, you would get the same answer? Would you believe it? Well, in fact, you would. And I urge you to give it a try. Make sure, prove it to yourself that it works. In the meantime, we have an exact value for x of 2. And for theta, we are going to, well, we're going to do it simply. We're going to know that the value for theta is the complement of 30 degrees. In other words, 90 minus 30 is going to give us what theta is. All right. You could also go 180 minus 90 minus 30 gives you the same thing. I'd like you to start thinking about that word complement, the complementary angle. All right. And so we'll just plop that in there. And we are done. Easy as that. All right. So So I promised to do one more question. I'm going to do, well, that's the question I promised to do. What the heck? We're on a roll. I'm going to do one more question. But I want you to give it a try first. I want you to attempt this first. So we're going to say bye-bye, bye-bye. Pause the video, pause the video. Hello, hello, hello. Hey, welcome back. All right. Last question I'll do with you. This is really your own homework, but I want to walk you through this a little bit, okay? X is the angle of interest. We have theta. Oh, heck, let's do theta first. Theta equals the complement of 45 degrees. So 90 minus 45 equals 45. What the heck? Let's put it in there. It's easy. It jumps out at you, and we're done. Now, if we're going to solve for x, then we have to set up an equation. And that equation is going to look something like, well, I'm going to take x and put it over the hypotenuse of 8, and I'm going to make it a trigonometric function. What should I do? Shall I use this 45 here? Well, x over 8 is sine of 45 degrees, isn't it? Okay. Could I have possibly used this one here? Could I have gone x over 8 equals the cosine of theta? Theta we know is 45. Okay, I'm going to leave that with you. I'm going to put this, I'm just going to leave this on the side here and get you to think about that. Conceivably, they would both work. But that kind of means that the sine of 45 and the cos of 45 are the same. But you know that already. You know that they are the same. So let's rearrange this formula here. And we would get, let's see, in terms of x, x equals 8 times sine 45. But we know that sine 45 has an exact value. It is root 2 over 2. So there we go. Now we can do some simplification, some, dare I call it, canceling out. And I would get, looks like 4 left. 8 divided by 2 leaves me with a 4 and a root 2. And I do believe we are done. No units, so we can use this as unitless. Back in my day, we never had units in high school. We would always say units or units squared or units cubed or whatever. Regardless, the exact value for x using the trigonometry you know and using no calculator at all is 4 root 2. And once again, I urge you to use your calculator to verify. Go 4 times sine 45, and you will see that you get the same thing as 4 times root 2. That's the magic of this kind of trigonometry, and that is the big secret. You must learn to either memorize or derive the exact values for these trigonometric functions, and dare I say it, more, but we're going to get that in weeks to come. You must either memorize these exact values for these trig functions, or else you must learn how to derive them using these special triangles there. Okay? All right, go forth. Populate your question page on page 231. There are 1, 2, 3. There's only 3 more questions left, so I've taken away. I may try to find some extra questions in the textbook for you. Go and do it, and we'll see you again next lesson. Cheers. Bye-bye. Bye-bye, Magic Love.